Welcome back. The next topic is logical operators. Logical operators are used when you want to test one or more conditions and make some decision. So, the logical operators in C language are logical AND, which is denoted by two ampersand symbols, logical OR, which is denoted by two pipe symbols, logical NOT, which is denoted by the exclamatory mark. But let us read it as logical AND, logical OR and logical NOT only. My dear friends, later on we are going to discuss about bitwise AND and bitwise OR operators. Remember, logical AND require two ampersand symbols, logical OR requires two pipe symbols. These are used for different purpose. Please note that. And the definitions of this logical AND, logical OR, logical NOT are exactly same as what you discuss in your digital logic or discrete mathematics. Now, how the logical AND operator is defined? This is true when both the conditions are true. If both conditions are true, then only the logical AND between the two conditions is true. So, it is true when both are true. In other cases, it is false. And one important point to be noted about logical AND is, whenever the first condition is false, independent of second condition, the result is false. So, here the short circuiting will happen. So, you have to be very careful. Sometimes in the second condition, you may keep some assignment values. Such things will not be executed at all. You have to be very careful, because if this condition is false, without even evaluating the second condition, whatever expression is there in the second condition, without evaluating, the result is given as false. So, there is something called short circuiting. So, you have to be very careful. Okay? So, you write 0 and any expression you write, the result will be 0 only. Here you write any big expression, the result will be 0. So, if the first expression is false, independent of this second expression, the result will be false. So, short circuiting will happen. Note this. Now, look at this. Here A is 5 and B is 2. Now, I am considering this expression A is equal to 5. Double equal to means I am comparing A with 5. So, it is true. So, once it is true, it will verify the second condition. B, that is 2 greater than 5. 2 greater than 5 is false, 0. Now, 1 and 0, 0. If any one is 0, it is 0. If both are true, then only it is true. Now, A is equal to 5, it is true. Now, it verifies B less than 5, true, because 2 less than 5, true. 1 and 1, now you get one answer. Now, look at this, A greater than 5, which is false. So, immediately you get the answer 0. It will not even evaluate the second expression. Now, A greater than 5 is false. So, independent of this, see whether B less than 5 or greater than 5, it will not even evaluate the expression, sir. Okay? Suppose if there is some assignment or anything involved in that particular expression, it will not be executed. Generally, we try to use like pre-increments or post-increments. Okay? Those increments will not happen because short circuit happens. You have to be very careful. So, the answer is 0 here. Now, how logical OR is defined? See, this is false when both are false. That is, logical OR between two conditions is false when both are false. See, when both are false, then only it is false. The remaining cases, it is true. My dear friends, even here the short circuiting will happen. Whenever the first condition is true, independent of the second condition, we get the result true. For example, if you get 1 or any big expression, it is ignored and you get the answer 1. So, here also short circuiting will happen, my dear friends. Here also short circuiting will happen. Please note that. Now, look at this example. A is equal to 5 true. Now, true, so result is 1 independent of verifying this. A is equal to 5 true, so the answer is 1. A greater than 5 false. Now, the second expression is, or the second condition is evaluated. B less than 5, 2 less than 5 is true, because any one is true, then it is true. If both are false, then only it is false. Now, A greater than 5 is false, B greater than 5 is false, so the answer is 0. Logical not. See, logical not says sorry to the condition. That is, if the condition is false, not condition is true. If the condition is true, not condition is false. And remember, it is a unary operator. It is a unary operator because it requires single condition. Whereas logical and logical are binary. They require two conditions. This fellow requires single condition. So, we call it as unary operator. I want you to make note of this point, sir. Any non-zero value, suppose A is non-zero, it is considered as 1, true. Okay, 1 you may misunderstand, but it is considered as true, and true is interpreted as 1, true or 1. Note that point. So, when A is non-zero, in this particular case, not A becomes 0, that is false. This is very, very important, and we use this idea regularly with selection structures, even with repetition structures, because there is some condition which need to be verified. In that portions where the condition need to be verified, we use this idea, that is non-zero value is a true value. So, if you need to say A is equal to true, instead of that you can write simply A. And if you want to say A not equal to true or A equal to false, that can be written as not A. So, this idea is very, very important. With selection structures, with examples, I am going to explain that, my dear friends. Okay? Now, let us take simple example here. Suppose A is 5 and B is 2. Now, here A is equal to 5, that is true. So, not of that is false. A less than 5, false, not of that is true. A less than or equal to 5, true, not of that is 0. A greater than 5, false, not of that is true. A greater than or equal to 5 is true, therefore, not of that is 0. Now, let us see the precedence of these logical operators. My dear friends, the logical not is a unary operator, it is having higher precedence, and that is right to left associative. See, my dear friends, when I write not A, the meaning is first right, then left. Right to left association happens. So, first this not A evaluated, then not A is evaluated. Note that it is right to left associative. The logical and logical are, generally people think they are having equal precedence, that is wrong. Logical and is having higher precedence than logical or. Okay? So, within that there are two levels, that is logical and is having higher precedence than logical or, and they are left to right associative, my dear friends. Please note that and is having higher precedence than or. So, first and is performed, then or will be performed. Okay? Now, let us take some simple examples. A is 55, B 25, what is the value of answer? So, here if you see not 55 and 25. So, not is having higher precedence. So, first not 55, 55 non-zero. So, not of that will be 0. So, 0 and short circuit, 0 and anything is 0. So, 0 is assigned to answer. So, the value of answer for this will be, so here in this case answer will be 0. Now, let us take the second expression, not A or B. So, here also not is having higher precedence than or. Not A means not 55, that is 0. Not of any non-zero value is 0. Or, now because it is a or both are true or any one is true, then it is true. So, here we have to definitely check what is B, which is 25. 25 is considered as true, 1. So, it is same as 0 or 1. So, the result is 1. here 1 is assigned to answer. And if you consider the position of logical operators, they are not at the same level, sir, they are at two different levels. See, the logical not included in this unary operators, that is unary plus and unary minus, that is plus 5, minus 2, you write na, together with that it is included. Actually here we also get the pre-increment, pre-decrement operators, we not yet discussed, we are going to discuss them, okay. And you see logical operators precedence is less than relational operators and it is more than assignment operator. Okay. So, the position of logical operators is below relational operators and above assignment operators. Do not worry, sir, we not completed all the operators. After completing all the operators, I will give you a beautiful mnemonic to remember the order of precedence of operators. So, let us conclude this session with one example. What is the value of A? Now, look here, minus A plus not A. So, if you see minus A plus not A, actually it is minus 3 plus not minus 3. Dear friends, not is having higher precedence. Unary operator is having higher precedence than arithmetic operators. So, first not is performed. Not of any non-zero value is 0. Because it is non-zero, it is considered as true. So, not of true is false. So, it is becoming 0. Then here minus 3. Minus C, any unary operator minus of minus 3, even these are right to left associative only. All the unary operators plus minus, so this fellow also, even if you see minus 3, it is right to left associative. Minus of minus is plus 3. So, you get plus 3, minus of minus is plus 3. So, the result for this is 6. Okay. See, I already executed, I am just giving you the output, just go through it. The next example. Now, here the value of A is 2 and value of B is 1. Now, here C is assigned the value of A less than B. A less than B, 2 less than 1 is true? No, false. So, C value is 0 because 2 less than 1 is false. So, 0 is assigned to C. Now, here if you see for D, you are comparing A greater than B logical and C, that is 0 less than B, that is 1. Actually, 2 greater than 1, it is true. Therefore, even this condition is also verified. 0 less than 1, yes, true. So, 1 and 1 is 1. So, the result for this would be D. D value will be 1. So, what is that is asking what is the value of C and what is the value of D. So, C is 0 and D is 1. So, you can get C 0 and D 1, my dear friends. Let us run this code and verify the output. So, let us see the output for the first program. Let us run the code. The output is 6, that is for the first program. Now, let us see the second program. Okay. Let us run this code also. The output for this is C is equal to 0 and D is equal to 1. So, this is about your logical operators, my dear friends.